Welcome to ERC Tipsnology. In this video, we will be learning about voltage sources in series. Remember that a battery symbol looks like this. It has a long line and a short line with the positive and negative symbol. As you can see from here, we have point A to B with a voltage source of 1.5 volts between letters A and B. So the VAB will be equal to 1.5 volts. We may also draw the battery with two long lines and two short lines like this. As you can see, I put long, short lines, but it's still the same. It's still equal to 1.5 volts. We may write VS1 to refer to that voltage source also. So the V between A and B, or the voltage between A and B, is also equal to VS1, which is 1.5 volts. Now, on the other hand, we can also put two voltage sources, VS1 and VS2, and if you add them, VS1 plus VS2, we will be getting 1.5 volts for VS1 and 1.5 volts for VS2. So the voltage between A and B is equal to 3 volts. So there are two voltage sources here. Now let's try another example here. We have 1, 2, and 3 voltage sources, each with 1.5 volts. Therefore, the voltages or the voltage total between A and B will be equal to the sum of voltage source 1 plus voltage source 2 plus voltage source 3, or VS1 plus VS2 plus VS3. Now the value of VS1 is equal to 1.5 volts plus 1.5 volts plus another 1.5 volts. So the voltage between A and B will be equal to, if you add the first and the second, that will be equal to 1.5 plus 1.5, that will be 3, plus the third 1.5, then the total will be 4.5 volts between volts VAB. Now let's have another example, but this time let's draw it vertically from up to down. So we have 3 voltage sources with 9 volts each. What will be the voltage between A and B? So that would be the sum again of the 3 voltage sources. Let's write here VS1, and here we write VS2, and on the third let's write VS3. So considering the examples before, we have to add the 3, VS1 plus VS2 plus VS3, and what will be the answer is just the sum of the 3 9 volts batteries. So we have 9 volts plus 9 volts plus 9 volts. Of course, we would be getting 27 volts. So these are adding voltage sources with the correct connection, plus minus plus minus plus minus. Now let's try to have an example of 2 batteries connected in the correct way and one of them in the wrong direction. Let's say the voltage source number 3 is connected, instead of plus minus, we will connect it in minus plus. What will happen if we try to calculate for the total voltage? So the VAB will still be the sum of the 3 voltage sources, VS1 plus VS2 plus VS3, but we have to consider similar polarities. So here plus minus plus minus. So we have to add 3 volts plus 3 volts. But the third one becomes minus plus. So this is plus minus, but this becomes minus plus. So we have to consider this negative symbol here. So when we add it, we have to put minus sign on the third voltage source, VS3. Here we will put a parenthesis and a minus sign and the 3 volts for the VS3. So if we will use algebra to add this, 3 volts plus 3 volts will be 6 volts. And you have to know plus negative volts or plus minus will be minus. That's it. And so we will have 6 volts minus 3 volts. And the answer will be 3 volts. So this is the voltage between AB or VAB, or the total voltage if you want to call it that way. So again, this is plus minus, and we got 3 volts. We have plus minus left to right, 3 volts, but the third one becomes minus plus. Therefore, we did not just add it. We consider the minus symbol, and you have to remember that one. That when it is not in the same direction as the previous one, then you have to put the negative symbol or the negative sign there. I hope it's clear. And in algebra, plus minus is minus. Now let's have another example. What is the total source voltage, or VS tot or VS total, in this circuit? As you can see, I'm drawing 3 batteries and 1 resistor connected in series. Let's put here R, and let's call this VS1, let's call this VS2, and let's call the third VS3. And let's have here 6 volts each for the batteries. So what is the total of source voltage? We have to analyze and write what are the given here, and as you can see, we are required the VS total. So the given are 3 voltages, so we have to write VS1 plus VS2 plus VS3. And what's the value of VS1? It's equal to 6 volts, or all of them actually are 6 volts, and it's positive, negative going down. So the other one is also positive, negative going down. So we can write 6 volts also as a plus because it's in the same direction. But let's see the third one. Oh, it's again positive, negative. So we don't need to write minus. Instead, we will simply write 6 volts. Unlike the previous one, they have different directions. So 6 plus 6 is 12, plus another 6, that would be 18 volts for our VS total. So the answer, or for the total voltage source sum, is equal to 18 volts. And again, VS1 are just added because the direction or the plus minus symbols are the same for all of the 3 batteries. So plus minus, plus minus, plus minus. So we just added them. But if one of them is not the same direction, then you have to subtract. Now let's have another example. Let's say we have 4 1.5 volts flashlight batteries that are connected in series. What is the total voltage of all the 4 batteries, or we may also call it cells? So let's draw the schematic. And here I'm using 4 batteries, 1.5 volts. Again, you may also use just one long line and one short line. So we need to consider that there are 4 batteries here, and we are required to calculate for the total voltage of the 4 flashlight batteries. So this is very easy, because if there are 4 batteries and we just need to get the total, we just add them. And so if we add the 1.5 plus 1.5, we got 3, plus another 1.5, 1.5, which is also 3. 3 plus 3 will be 6. So it's so easy. Now let's see the second problem. How many 12 volts batteries must be connected in series to produce 60 volts? So we need to draw a schematic that shows the battery connection. How many 12 volts batteries must be connected in series to produce 60 volts? Draw a schematic that shows the battery connection. So let's underline how many 12 volts batteries in series do we need. How many 12 volts batteries in series do we need, so that we will have a total of 60 volts. So to make it easier to analyze, let's write the given. So we have a total voltage of 60 volts, and the required or the needed is how many 12 volts batteries in series do we need. So to solve this, let's write the formula that we learned, which is getting the voltage total. Let's say this is 60 volts, so we need the sum of the 12 volts battery. If we put one battery 60 volts, let's say equal to the first battery, so it will be just 12 volts. So we may write Vt is equal to 60 volts plus the first battery, which is 12 volts. It's not yet 60. So we can add another voltage source number 2. And if we add another 12 volts, 12 plus 12, we will be getting 24 volts. And this is not yet 60. So we need to add another battery. We will put VS3. So I have a mistake there. It should be VS3. So plus 24 plus 12, we will be getting 36 volts. And so VS1 plus VS2 plus VS3 plus VS4, please consider correcting that one. It should be VS4. So that will be 36 plus 12, that will be 48 volts. Plus VS5, we will get 48 plus 12, we will be getting 60. And that will be same with the 60 volts. So again, VS1 plus VS2 plus VS3, let's correct this one. And this is supposed to be VS4 and this is VS5. Plus VS4 plus VS5. And if we write it down, 12 plus 12 plus 12 plus 12 plus 12, we would be getting 60 volts as our total. Therefore, to get 60 volts total, this is the symbol for therefore, 3 periods. We need 5 12 batteries, 5 12 batteries, so that we will get 60 volts, which is very easy if you think about it. 12 plus 12 plus 12 plus 12 plus 12, we will be getting 60. So we need 5 batteries to have a total voltage of 60. Now, the second question is to draw the schematic. So it's so easy. We just draw 5 battery symbols like this. Or you can also use the 2 long lines and 2 short lines like this. And then let's label them with the 12 volts with the plus minus symbols to show it complete schematic. And there you go. You will have your schematic diagram, or the second question schematic. We can write also here the word schematic, and this is between A and B. But you may write only one of the 2 drawings. So this is called schematic diagram or schematic. So this is the schematic diagram of the 5 volts batteries, the 12 volts batteries. Now let's move on to the third problem. The resistive circuit given below is used to bias a transistor amplifier. Show how to connect two 15 volts power supplies in order to get 30 volts across the 2 resistors. So let's say we have 2 resistors connected here and we have a bias voltage in the middle of them. How will we connect 30 volts there? If we have 215 volts, we can connect the 215 volts power supplies in series like this. And so we will get 30 volts because 15 plus 15 is equal to 30 volts. Now, how will we get 30 volts on R1? Let's connect the positive end of the voltage source on one of the lines of R1, and the other end, let's connect it to the minus. So that will give R1, voltage R1, or we may call it V1, equal to 15 plus 15. Then we will get 30 volts for VR1. How about for R2? We will get also another positive line on at the top and connect it to R2. We may go around R2 to make it easy for you to understand. We will also connect it at the top of R2 over here. And the other one, we will be connecting on the negative side of the battery to the bottom or below the R2. And there you go, you have also the R2. Let's put plus minus also on our battery to show the connection. So the R2 is having a voltage R2 equal to 15 volts also, plus another 15 volts. And so we will have 30 volts as our VR2. And there you go, we have R1, VR1, voltage on R1 30 volts, and voltage on R2 equal to 30 volts. Now if this is difficult for you to look at, we can also write it in another way like this. We put the one resistor connected to the two batteries and another one parallel to the R1 like this, and we will be having the correct answer also. So as you can see, the R1 is connected to the top and the bottom of the 215 volts batteries, and it will give it 30 volts, and R2 is parallel to the R1. And when we have parallel circuit, the voltages will be equal. So the voltage of R1 is equal to voltage of R2. Now the total voltage is the sum of the two 15 volts batteries, so it will be 30 volts. Now on the voltage across R1, we may call it V1. This is the voltage on across R1 is the same because it's connected to the two voltage sources, so it will be also VS1 plus VS2. So to get the sum of 15 volts plus 15 volts, we will be getting 30 volts. And R2 will be also equal to V2, or the voltage on R2 will be V2, or we will just write here V2 also equal to VS1 plus VS2, which is also the sum of the 15 volts, which is also 30 volts. Now remember, the parallel resistors or will have the same voltages. So the V1 will be equal to the V2 will be equal to the VT, or the total voltage. So VT equals V1 equals V2 equals 30 volts. So this is our answer to this problem. To show how to connect the two 15 volts power supply to get 30 volts across the two resistors. Now let's have problem number 4 to determine the to know the total source voltage of the circuit given here. So we have two voltage sources, which is also plus minus here, and let's connect another battery here, which is minus plus on the left and plus on the right. And let's have 15 volts, 6 volts, and 9 volts connected in series to a resistor. So again, be careful with this because the direction must be the same. Okay, so 3 voltage sources is given or are given in series. So starting from the given problem, we have to write the given, and then we have to write what's needed or what's required. So the required is the total voltage source or total source voltage. So we consider the first voltage source. Let's write VS1, VS2, and VS3 to the voltage sources. Now look at it and look at them. Look at the voltage sources. Let's write here VST to represent the total voltage source. And let's put here letter A, and let's put here letter B, let's put here letter C, and letter D to make it clearer. So you consider the first one, letter A and letter B, you will see that we will have VAB. And then between B and C, across B and C, we will have a voltage also VBC, and between C and D, VCD. Now the VAB is also VS1, and VBC is VS2, and VCD is VS3. So if you look at it, this is plus, and if we look this way, that will be 15 volts and another plus, so same, plus minus, so we put 6 volts, and another plus, so we put 9 volts. We should draw a line so that we can look if it is in the same direction. Now if we add them, this is so easy. 15 plus 6, 21, plus 9, that would be 30 volts. So that's the total source voltage for this circuit. Now let's have another one, the fifth problem. One of four 1.5 batteries was accidentally installed or connected in the wrong direction in a flashlight. What is the voltage across the bulb? That's the question here. So as you can see, we have a given of four 1.5 volts batteries. Now think about it. We have four 1.5 volts batteries connected in a flashlight. Now the required is to get the voltage across the bulb. What would be the voltage on the bulb or on the light if one of the four batteries is connected in the wrong direction? So three of them correct, but one is wrong connection. So the solution here is to be able to do this is we have to consider again that one of the battery is in the wrong direction. So let's draw two batteries in the same direction. Let's draw another one in the same direction. Plus, minus, plus, minus, plus, minus. We call this VS1, VS2, VS3. And the fourth one, we will make it in a different direction. So as you can see, I'll draw here minus and then plus. Therefore, the VS4 will be in a different connection. So we have 1.5 volts, 1.5 volts, 1.5 volts, and another 1.5 volts, but this one is connected in the negative. Unlike the other three, plus, 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 this one becomes minus. So this is just an example. One of them is in the wrong direction or connection. So what will we do here? It's so easy. We will still add the four voltage sources. We will add them with the formula that we learned before, that the total voltage, let's call this one, to make it shorter, VT, equal to the sum of all the voltage sources. And then let's put all the 1.5 volts. But the third one, you have to put minus, all right? Minus or negative symbol there so that it represents in the wrong direction. So adding the three voltage sources would be 4.5, but plus the minus or plus the negative 1.5 volts, that will be in algebra, plus minus will be minus. So that will be 4.5 volts minus 1.5 volts. Therefore, the VT will be equal to not 3.5 but 3 volts. So the VT will be equal to 4.5 minus 1.5. That will be, let's write it again, 3 volts. That's the answer for this question about what's the voltage across the bulb. By the way, if we will connect the schematic here, you will see here, I will put the bulb symbol or the light symbol. This is the bulb symbol. Okay, that's it. And just to represent the bulb and just to make a clear idea what is a bulb, and then connected to the battery. So that represents the light or the bulb of the flashlight. So as you can see here, we have four 1.5 volts, but one of them is in the wrong direction. So plus, minus, but this one is minus, plus. That's it. That's the schematic diagram, and we get, instead of 6 volts, we only get 3 volts. Thank you. Please subscribe.